it had W 10 by 32, or whatever the case might be, these will all be called out that way. So let's say I've got a W 6 by 9. Okay. Because that's the same as that rusted one you're handling right there. That's a W 6 by 9.
Oh.
Okay. So what that means is, this is the shape that we're going to use. Okay. And of course, anytime we can buy from a foundry, we're saving money, right? Using a stock material. This is, and I'm going to put approximate height. And you'll see this common through all steel shapes. Now, it will not probably be exactly 6. It'll be 5 7/8, it'll be 6 1/8, whatever. It's going to be rounded to a 6, right? Then you have an X, which is just a nomenclature, and then this is the pounds per foot. Because steel is sold, marketed, and designed for by weight. By weight, or volume of material. So if I was using a wide flange beam, this is the note I would lay along the line. And the line is the center line. If I was using an S shape, all I do is same thing, just take this out and put an S here. Okay. That's the only difference. So that's these 4. Okay. Now we come into these 2 shapes, which are very similar. We call these channel. I haven't seen a lot of MC being used out there. Sean, you're a metal worker. Do you know any instances of MC? Okay, well, let's just leave it at that then. Maybe you folks will come across it. I've never really used it. I do use a lot of C-shape, okay, the channel. Again, same nomenclature if you're using channel, except then this turns to a C. Okay, and that's for a channel. And I have a couple of them here. I got one big piece in the back, it's too heavy to kind of pass around. But here's a couple different sizes. Again, this is good. It's, in essence, it's like an S shape, cut in half. In essence, that's it. You still got your web, you got your 2 flanges, okay? But here we don't need the other portion of it. So I'll pass these around, a couple pieces of channel to look at.
These are both
The C.
Yep, those are C shapes, channel.
And this is the W.
Okay, any questions about channel? Channel, by the way, is used really primarily for 2 areas, usually as a support for a platform or a floor. We also take it and cut it up and use it to manufacture clips and things of that because it's got a good handy shape. Next 2 down here. Tubing. We call this stuff a little bit different. This is HSS. And then it has the size dimensions. So this one's called out a little bit different. When you're doing tubing, it is HSS, it stands for hollow structural steel. And then you get the outside dimensions and the wall thickness. So you are using one of these. You're using an 8-inch by 8-inch by 1/4 inch. Okay. Where these are your outside dimensions. And this one is wall thickness. or how strong do we want it to be? This is a real common shape for columns. I got one up here. Okay. So you'll see this one. By the way, as you're handling this stuff around the edges, some of it hasn't all been ground out. I just rooted through K&T's dumpster and grabbed some stuff, so I didn't put grinder to it. Okay. Just be a little careful handling it. Okay. So here you can see this one I think is a 4x4, so 4 inches to 4 inches, and then 1/4 inch wall thickness. And you can get them 1/8 inch wall thickness, you can get them in heck, 1/2 inch, whatever the case might be. And it works great in this situation as a column. Okay. You can fill these up with another material like concrete or something. You're not going to make it any stronger. Okay. A lot of times you'll see, this is a common shape along with this one that you see in parking places, right? So you can't drive into them, and they're filled with concrete. In fact, you only see kind of the concrete on the top. Most of that, if we do fill it with concrete, it's to keep it from moving. Okay? Because concrete retains heat, right? That's what concrete is, a thermal retainer. So if you put this thing and it's in direct sun, steel fluctuates a lot with temperature. Okay? So, you know, if I had a 10-foot piece of this and it's sitting in the sun, I would not be surprised to see it move 1/4 or 1/2 inch. It moves that much. If I put concrete in the middle, the concrete will retain the temperature longer, and so it keeps it cool, or it keeps it stable, so it doesn't fluctuate as much through the temperature, heating, cooling cycles of our climate. Okay. But it doesn't make it any stronger. Okay. So this is tubing, HSS. Great columns. Bring me to the next one, pipe. Okay, these two right here. Pipe is our strongest shape, right? Circle. No weak spots in it. You know, when you got like a tubing, it's got a weak spot where that thing's been bent on the corners. Pipe doesn't have that weak spot, so it's a real strong shape. Works good for us. We use it in trusses, we use it for columns. Not many beams. Those are the two places it really excels. This is just a couple smaller pieces that have been put together to just show how, you know, I could even make a bracket for a door out of this stuff if I wished. This is pipe, our strongest shape, if you really got to get it. It's hollow inside. So generally you have an outside diameter and an inside diameter. Or it's called out by outside diameter and wall thickness. They don't have one of these in this chart. This is just called a round or a bar, whatever you want to call that. It's called both things. In essence, just a circular piece that doesn't have a hole in the middle. Okay, it's solid. This is one that's kind of been formed like an anchor bolt, right? But it's not threaded on one side. This would be a good hook though, okay, or something of that nature. We take this, you see this used very often by itself. This is usually cut up and welded to other pieces to help them perform the job they have to do, like hooks, those types of things. Okay. So this is bar. So it's solid. They just have a couple structural stuff down on the bottom that we can still use that's cut up. I haven't hit these two yet. These are maybe our two most versatile ones. We call them angle. Again, we can use these for a lot of different things. I got one right here. Just due to its shape, it makes great hangers, trusses, things of that nature. Due to the fact that it has two strength axes, it's got one through here, it'll resist two forces. Okay. Now, it also makes a great shelf. Like I can take this, put a couple holes in, bolt it to a wall, and I can hang something on here, right? I just set it on there like that, and weld it or bolt it or whatever I need to do. Okay. So we see this really chopped up and fabricated into a lot of other parts. You'll also see this shape used in a structural sense in that We see it a lot. In fact, as you walk out, look through the windows and look at the back wall out there. A lot of times when we're doing sideways forces like shear, this is the piece that's added to handle that. Right? And we've talked about wall shear, like where wind blows against the building, wants to push it over. Remember you had to do those BT brace wall panels, BWPs. Okay? In essence, this is one of the great things for it, if we can do it. Our building is done with these, piece of angle iron that's welded in to withstand those forces. And you'll see them on that back wall back there. But
How is it, I mean, is it, I don't understand how that helps with the shear.
because we got standard studs in this orientation, something pushing that way. Well, if I take two studs and I take one and run it cross bracing, okay, let me draw you a picture. So I might have, hey, I've got a column here and a column here. Hey, I'll go ahead and maybe put a piece of angle from there to there and from there to there and make them rigid. So if the wind blows here, hey, this is holding it, right? Wind comes from this side, that one's holding it. Okay, we're good to go.
So the angle is overlapping part of it.
Yeah, so you either gotta offset them, or maybe you cut one to let it slip by the other, whatever the case might be. Okay. Real versatile stuff. Okay, you'd be hard pressed to find a fabrication shop that didn't have tons of this stuff laying around. Okay. This is a fairly big one. You can get them small, you can get them large. By the way, that one is called out by the legs. Okay. So it would be 6 by 6 by a quarter, or something of that nature. 4 by 4 by a quarter. 6 by 2, which means one leg's 6, one leg's 2. Thickness is a quarter. Okay. You can get a lot of different types on that. The last one that's not up there is this stuff. Again, not really used as a structural item in its original state, plate. Okay. You can buy this stuff huge, right? Biggest can fit on a truck and get moved. But it's basically just a constant plate. Then we cut it up and we use it for clips, we use it for fasteners, a lot of different things. And I got a couple different types here, just so you can see how this stuff works. Okay, this one's 3/4. I think this one looks, what, about 3/16 maybe. Okay. This thing right here, you're gonna kind of be amazed at the weight that this stuff has. And that's kind of one reason why I carry this around. But we would take something like this and cut it up and fabricate clips and hangers and stuff like that out of it. All right, so those are your standard shapes that you can buy and that we use in a structural sense. Now, obviously, we do manufacture different parts of this. You know, like we mentioned, that plate right there was used as the supporting thing of those haul trucks that Western Trailer was putting together. They just took that stuff, bought it, cut it up, welded it together, and they're off and running with a good structural beam. Okay? So you can do a lot of different things with this stuff. So to recap, steel, structural steel, made of iron and carbon in varying amounts. Typically, you'll buy it in 36 or 60 KSI. It is our all-around material. It excels in tension, but it handles compression very well. You still have to protect it from the elements. It is carbon-based. You should know your shapes. Okay, so spend some time on this chart. And that's the big thing, is because you as a drafter, do you have to know how to weld all this up? No, you don't. But you do have to know how to draw the line on it and apply the correct note. So if somebody tells you, hey, we're using W's here, you should know what that is. Okay, in varying sizes. Let's see, what else? Oh, strongest material per volume. Okay. So we can put a lot of it in a small area. Now, when I say strongest material per volume, keep in mind I'm comparing and contrasting 3 materials only: concrete, steel, wood. Obviously, like I mentioned, spider webs and stuff, you can find stuff much stronger than steel. And we've got alloys that will just kind of blow your mind on what they can do. But those are real special cases and a little kind of beyond what we're going to talk about here. Okay. Any questions on what we've talked about? Okay. Should we look through some drawings, or do you want to just kind of take a break and come back and do some design on it? What do you want to do? Should we let you look through the drawings? That's kind of what I'm asking. Do we want to do that as a group?
I think I'd like you to go through a drawing.
And just see how it's used? Okay, let's just kind of jump back there then, and let's grab a structural drawing, find some stuff that will match up with what we can see in the hallway, and look at how they drafted it up.
So Mike, this is reline. Reline is.
The ribs in it. It's pretty much the only thing that
The difference.
differs in, yeah.